But I love getting to know you, and hopefully this is getting you a chance to get to know other people as well who might have similar interests as you. I am going to go ahead and send out the links to the notes in the chat box. Again, you do need to try both links because one will work and one won't. It depends on if you are a Larkin student or a Cruza student. So there you go. There are the links in the chat. Again, try both links. And the reason you need to have your notes open is because doing your notes during class is a part of your attendance credit. So you obviously get your notes points, but if you also want attendance, then you need to be doing notes during class. All right, so you need to be on time, stay to the end of your class. I do need to see in the attendance report that you were here the entire time. And that includes that you need to be participating, because if you aren't participating, then I do excuse you for non-participation, at which point the attendance report will no longer show you being here the entire time. So make sure that you're participating. And then don't forget that, again, you need to be doing the work that we're doing in class to get your attendance, which means that we need to be doing our notes. Again, there's no like word of the day. You just need to be here and doing the work. Okay, so you complete your notes during class. I do check the timestamp to make sure that it is happening before the recording gets uploaded. Recording gets uploaded around 1 to 2 p.m. So just submit your notes right after class and then make sure that you pass them, because I do give you all the answers in class, or most of them. Okay. Smiley faces or emojis or yeses in the chat if you understand that policy. Again, this is actually also the answer to question number 1, is that you understand this policy. Looking good. All right, perfect. So this is a reminder, please do not share contact info. Please make sure you're participating often and well. Again, you get 3 chances. And then don't forget to behave appropriately. And remember that these are being recorded for learning purposes. Yeah, so Lexi, I always tell you when to answer each question, so you don't need to worry about the notes right now until we actually get to it. So whatever works for you, I'm flexible with that, but just when we get to it, just make sure it's filled in at that point, okay, by that point. All right, today is day 2 out of 60. We are going to be going ahead and talking about dimensions. I actually renamed this one to say measurements instead, just because we don't use the term dimensions very often. So we'll be talking about measurements today. Tomorrow you will start your Unit 1 project. Your Unit 1 project is pretty simple, seeing as it is your first project. And tomorrow you're just starting it. There won't be a lot for you to do because you haven't learned very much yet in our class because we just started school. Okay, so tomorrow there will be a recording posted. So during your normal class time, when you would normally have science classes, remember science does not meet on Thursdays. So during your normal class time, just watch the recording, work on your project, start it off. Again, it's pretty short and simple to get it started. And that way you can come back on Friday and be ready to go. All right, so I recommend just do it during class time when you would normally have me. That way you don't have to do anything outside of your normal work time. Okay, so that's what's coming up. Let's go ahead and take a look at our objectives for today. So we should be able to use the metric system to describe the 4 fundamental quantities. Identify the relationship of derived units to fundamental units, and define accuracy and precision and apply those to some actual data. All right, and today we will be working on the 1B notes. So I'm going to go ahead and one more time send out the link to the notes. So here again is the Larkin version. Here is the Cruza version. Again, you're either my student, a Larkin student, or you're a Cruza student. So make sure you try both links, because one will work and one won't. Go ahead and raise your hands when you have it open and ready to go. If in doubt, you can always go to your grades tab, and everything's already in your grades tab too. So just click on the grades tab, scroll down, find the 1B notes, click it, and then click start quiz. That's another way to get to it. While you're at it, please answer question number 1, saying that you understand the attendance policy. And raise your hands, go, go, go. I'm going to go ahead and give you 20 seconds to get this ready to go, because I've already asked you to do it multiple times. Again, you get 3 chances to respond. So if I don't hear from you, this counts as your first chance. Go, go, go. 15 seconds to raise your hands. I want you to imagine that you are trying to tell someone with a broken GPS, a broken phone, or whatever, directions to the closest coffee shop. I want you to tell me, what would you tell them to make sure that they got there? So tell me directions, tell me how far they should walk. Go ahead, write on the board or in the chat, what would you tell someone on how to get to the closest coffee shop? Go ahead and tell me on the board or in the chat. Excellent. So I see Joseph says that we should make sure to talk about street names. Street names, what else? Awesome. I see walk 3 miles south and turn. So I can see that we're talking a little bit about like the direction, right? Go ahead, get some more answers up there. We've got direction, we've got some distances, right? So 3 miles is a distance. Which way should they turn, right? 3 miles south and turn. I don't know which way to turn. Again, tell me, try to be specific. How would you get me, for example, to a coffee shop from where you are? Go ahead and tell me on the board or in the chat box. I see Lexi, I see Angelina working. Again, I saw Joseph. I need more participation. Brianna, Caden, Edwin, Malachi, Jalen, Jaslyn, on the board or in the chat. Answer this question. How would you tell someone how to get? I'm not asking for raised hands. I'm asking for you to participate. There we go. Perfect. All right. Awesome. Lexi, walk half a mile, then take 2 lefts and 4 rights. Wow, that is quite a bit. So 2 lefts and 4 rights. Yeah, so we have to tell them which way to turn. Which way to turn. Excellent. I see that up on the board. What else am I seeing? Show them a map. Right. So we're just assuming that if you didn't have a map, how would you tell them? Yeah, location marks. That's a great one too, right? We could tell them specifically, right? Like you'll see a McDonald's, right? You'll see a McDonald's, or you'll see something, right? You'll see a landmark. Let's see here. Only Starbucks in your area. There we go. Cool. All right. So what I'm seeing here is that we are talking about a bunch of different things, right? So there are a bunch of different ways that we can explain directions. But directions to a place, you need to first tell them which way to go. You need to tell them how far to go, and you need to tell them when do they need to turn and in which direction do they need to turn. And even if you use a GPS or you use a map, they still need to be able to understand those things, right? Looking at a GPS, looking at a map, you still need to understand which direction do I start? Which ways do I turn? And how far do I need to go? Do I go a mile? Do I go a foot? Right? There's a lot of different ways that we can explain how far to go. So to go 5 blocks, take a left, go another 3 blocks, take a right, follow the road to town. There you go, Jalen. That's excellent instructions. Go ahead, give me a green check, orange X if this is beginning to make sense. That when we talk about directions and we're trying to be specific, there's a lot of different things we have to think about, right? The actual direction, the actual distance, right? All of those things. Green checks, green checks. Excellent. Brianna, Caden, Edwin, Malachi, green checks. Tim, Jared, Sierra, Shayna, great. Thank you, Shayna. Anissa, sorry, Anissa, maybe I just don't see yours. Anissa, green check. Mallory, Kamal, Alicia, green checks. Matthew, Cody. There we go. Perfect. Seeing lots of green checks. Awesome. Let's go ahead and keep on moving here. So the one thing I want us to focus on right now, we'll talk more about direction later, but for today, we're going to talk about measurement. So today we're going to talk about like the distance that you are actually going. Car trips, you're the co-pilot and you give directions. Yes, if you are in the co-pilot seat, you have to stay awake and you have to do the directions. That is true. So this leads us to this idea of measurements. So measurements tell us how matter and energy are related. So they tell us like what is the actual amount of something. Now, in the US, we tend to use the English system, which is probably more familiar to most of you if you've lived here your entire life, but it is actually more difficult to use. So you can see a graph here, for example, of them saying that this is random nonsense. So for example, there are 12 inches to a foot, but only 3 feet to a yard. And then there's 1,760 yards to a mile. And then 16 ounces to a pound. So this is just kind of random numbers that throughout history we have eventually come up with, but they're kind of arbitrary, right? So it seems a little bit more difficult to use. Now, most of the time, throughout the rest of the world and in science classes as well, we instead use the metric system. And the metric system is actually easier to use, which is why we prefer it in the scientific community. So for example, 1 centimeter is 10 millimeters. 1 meter is 100, oops, sorry, this should say centimeters, 100 centimeters, right? So you can see that this is much more logical, that for millimeters to a meter, it's 1,000, meters to a kilometer, it's 1,000, grams to a kilogram, there's 1,000, kilograms to a ton, there's 1,000, right? I know, our stuff is so much harder. Go ahead, give me a smiley face emoji or a yes in the chat box if this is beginning to make sense. I'm sure you've probably heard of like a meter stick before. But again, these are different systems. So just as a heads up, we'll be using most of the time the metric system. Excellent. All right, let's talk a little bit about that. So we are going to talk about what are called quantities. So quantities is another word for type of measurement, right? So when I say quantity, I'm talking about a type of measurement. So there are several fundamental quantities. In our class, though, we focus on 4 of them, okay? And the word fundamental means basic. So these are the most basic types of measurements. And we're going to, in our science class, be measuring them in what's called the metric system or what's called the SI system, the International System of Units, because again, it makes more sense communicating as scientists across the world to use the same system. So an international system, the SI system. All right, so these fundamental quantities are then measured in fundamental units. So fundamental quantity is the type of measurement. Fundamental unit is the actual unit that we use for it. So the 3 fundamental quantities we're going to be taking a look at today are distance, mass, time, and temperature. And their units that you need to begin to familiarize yourself with are meters instead of feet and inches. We don't use those in our class. We use meters. And the abbreviation there is an M. So for example, 3 meters. Mass is measured in grams. So we don't use ounces. We use grams instead in this class. So 27 grams or 27G. Time is measured in seconds. You should know what a second is, but we generally tend to stick with seconds more often than with minutes or hours. So seconds, an example would be 60 seconds. And finally, temperature is measured in degrees Celsius. So for example, room temperature is about 24 degrees Celsius. This is different than degrees Fahrenheit, which is what the US uses. So degrees Celsius is what the rest of the world uses. Go ahead and give me a green check, orange X if you're beginning to familiarize yourself with those, if you understand those. Again, a lot of those are probably familiar terms to you. It's just that I'm letting you know that these are the ones that we're going to use more often. These are the ones that we're going to use more often. Yeah, don't worry. You don't have to be good with it or anything. You just have to know that that's what we're going to be using. I'm not asking you to know everything about degrees Celsius yet. Just asking you to understand that in our class, we'll be using degrees Celsius. That's it. Perfect. All right, let's go ahead and move on here. So match these up for me on the board. Use thin lines. So the line tool can be found by clicking on the box and then clicking on the line. And again, please use the thinnest version possible. Any color is totally fine. Match these up for me. Distance, time, mass, and temperature. What is their fundamental unit? The 4 fundamental quantities we're taking a look at, what are their units? Go, go, go. Get your answers up there. Thank you. I see Lexi on the board. I see Joseph on the board. I see Angelina working. I see Shayna working. Thank you. Erica up on the board. Let's get some more people. Thank you. I see Lexi. Oh, sorry. All right, I see Itati. Awesome. Let me know if I'm saying your name incorrectly. I see Alexander working. There we go. Brianna, Kaden, get your answers up there. Edwin, Malachi, Jalen, Jaslyn. There's a lot of you. You should be participating. Again, participation helps your learning. Awesome. I see Jaime. Looking good. Get your answers up there, Jalen. Thank you. Excellent. Awesome. Let me go ahead and pause these tools. Let's see what we've got so far. So it looks like we said distance is measured in meters. That is correct. Time in seconds. Yep. Mass will be measuring in grams in our class, and temperature in degrees Celsius. Excellent. Go ahead and match these up for number 2 in your notes and raise your hand. You have 45 seconds. Again, you do need to be completing your notes during class. Otherwise, you will not be able to get your attendance. So go, go, go. 45 seconds. Raise your hands. So let's go ahead and talk a little bit closer, take a closer look at these different units. So again, fundamental quantities, distance, and the unit is measured in meters. So if you're not familiar with a meter is about 1 yard or 3 feet. So if you take a look here, all right, so here is 3 feet on my measuring tape right here, right? So here is, where am I? 3 feet right here. And then if you take a look at the underneath, right? So this would be 1 meter. So 3 feet is right here. 1 meter is right here. They're pretty close together. So 1 meter is about 1 yard or 3 feet. Smiley faces emojis in the chat box if that makes sense. So if you're familiar with meters versus if you're familiar with yards, okay? Now, there are actually small versions. So if you take a look at like the little marks on a ruler, you could also see millimeters and centimeters. So for example, you will use these when you're talking about small distances. So for example, 2.2 centimeters is the same size as 1 inch. Or there's also larger versions. So you could also, instead of using meters, you could use kilometers, which also has meters at the end of it. So kilometers, like a 10-kilometer race, is about 6.2 miles. So again, just familiarizing you with these different types of measurements. But the reason that we use these again is this is a lot easier to use in science class. It's a lot easier to say 1 centimeter is 10 millimeters and 1 kilometer is 1,000 meters. So when we have those tens, hundreds, thousands, it makes it a lot easier to convert and to understand what's going on in a science class. Now, time you should be pretty familiar with. Time is measured in seconds. 1 second is about 1 heartbeat. So if you think about how long it takes for your heart to beat, that's about 1 second for most of us. If that's not true for you, if it's significantly faster, maybe ask a doctor about that. But 1 minute is 60 seconds. We know that 1 hour is 60 minutes and 1 day is 24 hours. We should be pretty familiar with that since we use time pretty much the same as everybody else. Now, mass, our third fundamental quantity, is measured in grams. Mass is the amount of stuff that an object is made up of. It is similar to weight. We will be talking about in a later unit how mass and weight are not identical, but they are similar to each other. And we often use them very similarly. So an example here is 1 paperclip. All right, so if you see one paperclip here weighs about 1 gram. If you see down here, you can see an example of an apple. If you ever use a kitchen scale in grams, an apple weighs about 70 grams, okay? And then a human, a 120-pound human, weighs about 54,400 grams. Or again, the nice part about this is it's easy to convert. So instead of saying 54,400 grams, we could also just say 54 kilograms. All right, go ahead and give me a green check, orange X if you're feeling comfortable with those so far. All those different units we've talked about so far. Again, just kind of giving you examples of where you might use these in real life. Yeah, I use a kitchen scale all the time because kitchen scale actually allows you to be more precise when you bake or make food. So I definitely use a kitchen scale quite frequently. Cool. Now, temperature again is measured in degrees Celsius. Now, degrees Celsius is unique from degrees Fahrenheit. Degrees Fahrenheit was made kind of based on how temperature feels to you as a human. But degrees Celsius is actually based more scientifically on the temperature of water. So 0 degrees Celsius is the exact temperature at which pure water freezes, and 100 degrees Celsius is the exact temperature at which pure water boils. So that's why we use the Celsius scale more often in our class, is because it's actually based on something that's a little bit more scientific. All right, let's go ahead. Fahrenheit is used in very few countries, but to get you familiar with temperature versus, with Celsius versus Fahrenheit, let's go ahead and take a look at this demo here. I'm going to go ahead and share this with you up on the board. And I'll also put this link in the chat box for those of you that would like to play around with it yourself. So let's go ahead and zoom in here. Make a nice big. Okay, so taking a look here, you can see at 0 degrees Celsius on the left, which is about 32 degrees Fahrenheit on the right, what state is water in? Go ahead and tell me in the chat box. Is it a solid, liquid, or gas? At 0 degrees Celsius or 32 degrees Fahrenheit, what is water? Yeah, that's when water becomes solid, exactly, ice, and that's also when it begins to snow outside. So if we're saying, oh, it's really cold outside, it's about to snow, that means that in America, that means it's less than 32 degrees Fahrenheit, but in the rest of the world, that just means it's less than 0 degrees Celsius. So again, that's why they often use 0, because 0 means freezing, okay? You can get even colder, right? So you can see very, very cold, very, very cold. Now, if we start to get warmer though, let's go ahead and take a look at a nice sunny day. So 70 degrees Fahrenheit, all right, right here is about 21 degrees Celsius. So when we say room temperature, we'll often say 21 degrees Celsius or about 70 degrees Fahrenheit. So again, that's a comparison. It's a little bit weird because I know that Celsius seems really cold. You're like 21, that seems cold. But again, Celsius is a different scale. Now let's keep on going. About 100 degrees Fahrenheit, really hot, is only 38 degrees Celsius. So it's getting hotter here. Is that a joke, Angelina? And then keep on going all the way up to 100 degrees Celsius. And that's when you finally get to boil water. Oh no, I did not hear about that. That's not good. So 100 degrees Celsius, again, is when water begins to boil. Whereas for Fahrenheit, it's 212 degrees. It's a kind of an arbitrary number. That's why we prefer Celsius, because Celsius is based on when water freezes and when water boils. Go ahead and give me a smiley or an emoji or a yes in the chat box if this is beginning to make a little bit more sense now that you've seen them side by side. All right, I really like this demo. I feel like it makes a lot more sense than trying to do like a math conversion between the two. Excellent. All right, let me go ahead and jump back over to our PowerPoint here. And let's do this. Yeah, it makes their winters less extreme. That would make sense. Go ahead, practice this for me up on the board. Which of these units, all right, is best approximated by what we have over here? Go ahead and match those up for me. A meter, a second, a gram, 0 degrees Celsius, 100 degrees Celsius. Is that approximately 1 paperclip, 1 heartbeat, when water freezes, a little over a yard, or when water boils? Go ahead, get your answers up there. I see Shayna working. I see Edwin working. I see Joseph on the board, Angelina on the board, Lexi, thank you. I see Jaime on the board, Kamal working. Great job, everyone. Itati, Lena, thank you. Beautiful, looking good. All right, let me go ahead and pause those tools. Let's see what we got. We said 1 meter is a little over 1 yard. Perfect. A second is about a heartbeat. Yep. A gram is about 1 paperclip. Yes. 0 degrees is when water freezes, and 100 degrees is when water boils. Excellent. This is going to be number 3 in your notes. Please raise your hand when you have number 3 ready to go. You have 45 seconds to work on this. Go, go, go. Please answer number 3. Again, if you want attendance, you do need to be doing your notes during class. So it's not enough to just log in and sit here. You do have to be doing work. Let's talk a little bit about derived units. So derived units, on the other hand, right, we talked about fundamental, meaning the most basic units. Derived units, on the other hand, are going to be combinations of fundamental units. So these are when you take the fundamental units and you start putting them together. An example here would be volume. So volume is a derived quantity, and it's going to be measured in a derived unit. Now, volume is the amount of space that an object takes up. If you remember math class, for example, calculating the math of a cube or a rectangular prism is calculated by multiplying the length times the width times the height. Go ahead, give me a smiley or an emoji in the chat if you remember that from math class. Again, there are other similar equations, right? I know it gets a little bit trippier once there's like triangles and stuff involved, but in general, you're taking the 3 sides of the shape and multiplying them together. Okay, so this is going to end up combining the units together because length, width, and height are all distances. And so we measure all of those in meters. And once we start to combine them, we multiply them together, you end up with a unit that is made up of more than the fundamental units. Let's go ahead and take a look here. So an example here is volume, again, equaling length times width times height. In this example, I could say that the length of my cube is 1 meter. Right, sorry, grab my tools here. Is like 1 meter, okay? And then let's say the width of my height is also 1 meter, so 1 meter. And let's say the height of my box here is also 1 meter. So tell me in the chat, 1 times 1 times 1 should give me what? So first, let's address the number. 1 times 1 times 1 should give me what? We're multiplying, we're not adding. So 1 times 1 times 1, anything times 1 still equals itself. So 1 times 1 times 1 should just equal. Awesome, I see Lena. There we go, Angelina. Lexi, yeah, it's just gonna equal 1, so 1. However, when you have 3 of the same thing and you multiply it together, meters times meters times meters, you are actually getting something that is cubed. So if you take a look here, the units here are actually 1 meter cubed. All right, go ahead and give me a green check, orange X if that's beginning to make sense. That's like 2 times 2 times 2 is the same as 2 cubed. All right, so meters times meters times meters is the same as meters cubed. Okay, so this is an example of a derived unit. All right, it's a combination of meters 3 times. All right, so it's a derived or a combination of a fundamental unit. So anytime you see things being combined or put together, that makes it a derived unit. Now, oftentimes in our science classes, it's a lot harder to say meters cubed. And so instead, we replace it with a name called liters. So 1 meter cubed is the same as 1,000 liters. How many of you have ever had a 2-liter bottle of soda? How many of you have ever had a 2-liter bottle of soda? That's a great visual of what a liter looks like. So half of a 2-liter bottle, that is a liter. Yeah. So we often use liters again because it's a little bit easier. It's technically not an SI unit, a international system standard unit. The technical unit is meters cubed, but liters is a little bit easier to use. So we often use liters more often in science class. Just as a heads up, meters cubed, same as 1,000 liters. They're very easy to convert between, which is why we still use them. Okay, perfect. Let's go ahead and take a look here. This question, number 4, you need to be able to do on your own. Again, it's a very simple question, though. You need to choose all of the following that are examples of derived units, meaning combinations. So you need to find the ones that are combinations. Easy peasy. This will be number 4. Your options are degrees Celsius, meters, meters per second, or meters divided by seconds, seconds, kilogram meters per second, which is the same as kilograms times meters divided by seconds, or kilograms. There's going to be more than one answer. This is the number 4. Again, you need to do this one on your own. If you want to double check your answers, I'm in the Q&A area, but please do not put answers in the room chat. You have 30 seconds to work on this. Go, go, go when you have number 4 completed for combination units. The last thing we need to talk about is just accuracy versus precision. So accuracy is how close you are to the true value. In other words, accuracy is how correct you are when you measure data. So this just tells us that when we set up tools and stuff, we need to make sure that they're set up or calibrated correctly, because otherwise your measurements will be incorrect. So for example, if you turn on a scale while you're standing on it, then all of your following measurements will be incorrect. All right, you have to make sure you calibrate things correctly so that you have correct values. Precision, on the other hand, is how close the values are to each other, meaning how repeatable your data is. So this means that you need to use the same tools, the same samples, the same supplies when you do an experiment to try to keep things as similar to each other as possible. So you can see an example over here, right? If we have high accuracy but low precision, this means that you're getting the right answer, but you're not always getting the right answer. If you have low accuracy and high precision, that means that your answers are all close to each other, but they're not the right answer or the right data. And if you have both, then that means that you are consistently always getting the same data, the same answer. It's both precise and accurate. Smiley faces emojis, everyone, if you understand. Smiley faces emojis if you understand. Oh, wait, sorry, hold on. Perfect. Okay, good. So taking a look at an example, this is number 5 and number 6. Go ahead and fill in these blanks for me really quick. All right, I apologize. We're going to go a little bit over, so just stick with me. All right, I'll try to be quick. 20 seconds to fill out number 5 and number 6. Make sure you spell them correctly. You just have one question left, so go, go, go. Let's go ahead and just do a practice, because the next one you do need to do on your own, and then I will go ahead and dismiss you after that. So just stick with me. Remember, accuracy is how correct you are. Precision is how repeatable something is. So taking a look here, is this correct? Is golfer 1 correct? Is he getting to the actual place he should be? Yes or no? Is he correct? Yes or no? No, he is not correct, and therefore this means that he is inaccurate, right? He is not accurate, he is inaccurate. On the other hand, is he precise? Are all of his golf balls going to the same place? Yes or no? Are all of his golf balls going to the same place? Yes or no? Yeah, exactly. So this would actually be precise, okay? So he's inaccurate, he's getting the wrong answer, but he is precise because all of his data is in the same place. What about golfer number 2? All right, golfer number 2, is he correct? Is he getting the hole-in-one? No, so he is inaccurate. And let's talk about precision. Are all of his golf balls going to the same location? Is he repeating the same data? No, so this is also imprecise. It's also not precise. Okay. Finally, golfer number 3, is his data in the correct spot? Is his data in the correct spot? Yes, so this makes him accurate. And is all of his data repeatable? Is it going in the same place? Yes, so this also makes him precise. All right, go ahead and give me a green check if you feel like you would be able to do one on your own, because you will be expected to do the next one on your own. So go, go, go. Give me green checks. All right, let's try this out then. So question number 7, please complete this one on your own. If you want to check your answer in the Q&A area, that's where I will be. A thermometer is placed in a refrigerator. It is read 5 times as 4.3 degrees Celsius, 4.4, 4.4, 4.3, and 4.2 degrees Celsius. The real temperature is 3.7 degrees Celsius. So is this data only accurate? Again, accurate means correct. Okay. Is it only precise, which is its repeatability? Okay, how close the data is. Is it both, or is it neither? Okay, so go ahead, do number 7, and then raise your hands, and then I will go ahead and close you out. So 30 seconds, and then we can go ahead and finish up. Work quickly. We talked about the metric system, fundamental quantities versus derived ones, and accuracy and precision. Make sure that you answer that last question, saying that you understand that you need to do your projects. That will start tomorrow. You will have a recording instead of live class to start you on your project. Make sure that you pass your notes, and I will see you all later. Submit them now. That way you get your attendance. Thank you so much, everyone. I will see you later. You have 30 seconds to go ahead and log out. Have a wonderful day. I'll see you back here on Friday. Bye, everybody. Thanks for working so hard.